All right, I always find chemistry kind of dry, so we're going to give you some examples uh, in biology, some applications. So these are just some examples of important molecules and how they kind of impact us on a daily basis. So I got a picture of a baseball player there. He's retired about 25 years, but they were important guys and it kind of showed the importance of one type of organic molecule. So remember, organic molecules are large molecules with very complex structures. They're covalently bonded together and they contain lots of carbon and hydrogen atoms. And so we're going to talk about carbohydrates, lipids, nucleic acids, and proteins. The first one we're going to talk about are a group of molecules called the steroids. These are regulatory molecules that promote growth and development, and they're involved in sexual maturation and things like that. One big application of this is performance enhancing drugs, steroids, and probably the not the earliest use, but the best example of how effective some of these drugs are came in baseball. Baseball is unique among the sports in that you have tons and tons of information going back well over 100 years on the performance of individual players as far as batting and pitching goes. And so you can compare players from different eras and how well they're doing and things like that. And so if you look at this little table up here, you can see in 1927, Babe Ruth set the record for most home runs. Okay, that was in 1927, yeah, and so 60 home runs. So then 34 years later, finally one person broke that record. Roger Maris hit 61. Okay, most years between then, only one or two people could hit 50 home runs. Many years, nobody hit 50 home runs. Roger Maris's record stood for another 38 years. Then suddenly, two people, Sammy Sosa and Mark McGwire, started breaking that record almost every year. In 1998, Sammy Sosa hit 66 home runs. In the next year, he hit 63. 1998, Mark McGwire hit 70 home runs. 1999, he hit 65. Oh my gosh, suddenly two guys are breaking these records. And then there were more and more and more. And so these records were really allowed us to really identify, hey, this is something really unusual. And suddenly lots of players were doing that. One player, Barry Bonds, hit 73 home runs, even though he was walked almost 200 times. So this was just a really good example of how impactful these hormones are. If you go to the PowerPoint, there's nice links showing pictures of some of these hitters before and after they took steroids. Some of them were not great players. Jose Canseco was one of the guys that hit 60 home runs. There's more than just here, uh, but uh, but they could do it. And some of them admitted it, others haven't, and so we can see that. And in professional sports, we can see, oh, there have been changes, but it's harder to find individual performance data that goes is as good in baseball. One indication is in professional football, the weights of players has jumped dramatically. Um, and after they started testing for performance enhancing drugs, uh, there's lots of suspensions in football. Unfortunately, we can also see some of the negative effects. Really more severe injuries, decreased life expectancy, more cancers, things like that. So a good example of how effective these are. All right, let's talk about another type of molecule, proteins. Proteins are made of amino acids. These are contain carbon and hydrogen, nitrogen, and oxygen linked together in long chains. Proteins are really useful. We use them for lots of different effects. Okay, one protein that I'm sure you heard about is hemoglobin. Hemoglobin is a protein, actually four protein chains that are 498 amino acids long. Each one links to a heme unit, which is a porphyrin ring containing iron. And what this does is that hemoglobin is able to bind to oxygen, okay, and it binds to oxygen in the lungs and it carries it to the tissues. There it picks up carbon dioxide, which it can carry to the lungs. A single ch amino acid change can reduce the effectiveness of hemoglobin. And so really important that its structure matches exactly to do its job. Another good example of the effect of a organic molecule on the body is our nucleic acids. Remember, we have DNA and RNA, and these are involved in heredity and protein production. DNA is a double helix that contains two strands with a specific sequence of bases. And these bases can be converted into a sequence of amino acids in a protein. Okay, a big example of a change in DNA is a mutation associated with what's called lactase persistence. All mammals make the sugar lactose, that's a carbohydrate, and they produce it in their milk. It's a sugar you really don't find in any plant foods, only in mammals, only in milk. Mammals then, when they're young, produce an enzyme called lactase, which is needed to digest that sugar. Okay, most mammals stop producing this enzyme in adulthood. They don't need it because they stop drinking milk. Humans, some of us, have a mutation that allows us to digest milk even as adults. We can continue to produce the enzyme lactase needed to digest the sugar lactose. And here you have a map that shows the darker areas show where these mutations have occurred. So there's one region in Northern Europe, one region in Western Africa, and then a large region in the Mid East where you find this mutation. It's associated particularly in areas that are dry and in areas where they raise animals, particularly cattle, for dairy. So you find this in large parts of the world. These are mutations that are common in people of Northern European, West African, and Middle East descent. For people that don't produce this, they are lactose intolerant. Okay, as adults, they don't make the enzyme lactase and they can't digest lactose. If they eat dairy products, they will get sick. They will uh, Lactose will pass through and cause diarrhea. And so it causes these symptoms located on the bottom. These people can still eat fermented dairy products because the fermentation process removes lactose. Okay, and so they can eat yogurts and kefirs and cheeses. If they want to drink milk, they have to consume some of the enzyme lactase. Okay, and they can do that in the product of lactose or lactate. Uh, this kind of brings up some kind of things that I laugh about, but are pretty serious. Sometimes it's important to know what you know and know what you don't know. Uh, Many people have thought the production of lactase in adults and humans is a big advantage, and it is if you have dairy products available. But you have to kind of know things about the world before you make other conclusions about this. And so here I have a chart that shows the relationship between confidence and how much you know. It turns out people are often very confident when they don't know too much. But as they learn more and more, they become less confident until at some point they know enough that they start to feel a little more confident, but they're never as confident uh, when they know something as they are when they don't. This is called the Dunning-Kruger effect. Um, Basically, it is these people don't know that they don't know. And these people know enough to know that things are complicated. And this is important when we talk about the misuse of science, because lactase persistence has been used by white supremacists as a symbol of what they think is their genetic superiority to everybody else. And so these guys, when they're uh, get together, sometimes they drink milk because they know some people it makes them sick. But what they don't realize is that this is not a sign of superiority. It's a sign that your ancestors raised cattle and did dairy. And of course, the biggest group of people that have lactase persistence are Middle Easterners and West Africans. This is not a factor that's only restricted to Northern Europeans. It's found in other parts of the world. So it's a good example of a little knowledge is a dangerous thing. They are not genetically superior. In fact, they share these traits with many people that they are prejudiced against. including Middle Easterners and West Africans. So, so a little knowledge is dangerous. Okay, so next time we're going to pick up and talk about cells.